Recording has started.
So we spent the last couple of classes talking about scientific notation. Did some converting, we did some operations with it, and then we looked a lot at those powers of 10. Just to let you know, there's a quiz out there for scientific notation posted for today out on Blackboard that is due tomorrow, so that's October 2nd at noon. So make sure you get that downloaded and completed and submitted back in. Anybody have any questions on scientific notation before we roll on? Okay. So today we're going to kind of continue on. The scientific notation fits in with the rest of Unit 3 because of that engineering notation and the metric units. So what we're going to talk about today is we're going to start talking about origins of measurement. We talked a little bit in the last unit about accuracy and precision and stuff like that. We're going to talk a lot more about where that comes from before we're done. But I want to look over what the units actually are and where they came from. Measurement really arose because of two needs. One was communication. Let's say we're both trying to build an object and we want them to be identical. Well, if we're working in the same room, it's not that hard to do. I can just walk over to you and take whatever piece you're having and mark mine off to be the same size and go cut it and back and forth. But if you're across town or in a different town, there needs to be some way to communicate what that size is. I suppose you could cut a string or a stick or something to the size and send that down. But it'd be nice to have some way to report several of them at once and sketch it out so you can see how they go to make it more efficient. So it's the communication side of it. The other is for record keeping. Now, not just to record what it was, but let's say I build something today and I want to be able to build another one in the future just like it if the need arises. So a year or 2 years from now, I can have that record that I can go in and I can make another one just like it. So to do that, they started measuring things. Let's say I wanted to describe to you the size of this piece of paper. Well, I might take my pen and say, okay, it is this 1, 2, it's just under the piece of paper, is just over 2 pen lengths in size. So I send that message to you, hey, it's 2 pen lengths. You take your pen and you go 1, 2, well, you can see 2 pens is actually past the edge of the paper, so a little over 2 pen lengths for you is somewhere in here. So that communication failed because I'll put my paper behind it so you can actually see them in the limited light. The pen you used was longer than the pen I was using. So that communication failed. So for measurement to work, 2 things had to happen. We had to use something that both people would have, and the ones that each person had to be relatively close to the same size. So what they ended up using was actually body parts for the most part, if we're talking about length. So let's talk about standard units of length. And of course, the smallest unit of length in our standard system, at least that we commonly use, is the inch. The inch is actually the distance from the end of your thumb to the point of that first knuckle. That's an inch. So I could measure my sheet of paper here. I'd take my thumb and I'd go 1, 2, 3, 4, 5, 6, and count up. By the way, that little bit of a rolling motion you saw as I rolled my thumb because it's curved, that's where the name came for the inchworm, because it kind of moves with that same little bit of a rolling motion. So that's an inch. Bigger units? Well, the next largest unit that we typically use is a foot. And of course, all of you know there's 12 inches in a foot. Now, there used to be a lot more units, even between inches and feet, that we don't need anymore. For example, if I wanted to measure the height of this wall, I'm not going to go with my thumbs and go 1, 2, 3, 4. That'd take forever to go up. Well, not forever, but take a long time to go up that wall, crawling up it with my thumbs, measuring it out. With my foot, however, which would be the unit I would probably want to use for it, I could get up to about here with some serious stretching. But there's no way I'm getting my foot up to the top of that wall to measure it, unless maybe I chop it off at the ankle. Feet were used to measure things along the ground because that's where feet typically are, is along the ground. So to measure something that was up and down like that was too big to measure with your thumb with the inches, one of the units we used was the hand. You'd stack your hands like this. So the hand was actually defined to be the width of the hand at the base of the fingers here. Traditionally, the conversion works out to be 4 inches. Actually, there are a couple things that they still use them for most livestock. Horses, cows, sheep, goats, they still use hands as a comparison for measuring height. In the 500s, King Edward declared that his thumb and his foot, his hand, his everything were going to be the official measuring units of the kingdom. So instead of people using their own thumbs and their own feet, the foot obviously is from the back of your heel to the tip of your longest toe. They came in and they took his foot and they marked it off on a piece of wood and they cut it and they made a bunch of them and passed them out for everybody to use for measurement. And they did the same with his thumb. They marked it out, cut those blocks, and they sent them out. Well, because people now had this device, this block of wood to measure with, they didn't have to get their foot all the way to the ceiling anymore. So now they could use that block to go up the wall and measure without having to worry about getting their foot up there. So units like the hand became not as necessary anymore. And of course, the next set in evolution of measurement at least, was they took that block for, actually usually they used the inch to start, was the first one they used. They took that little block for the inch and they took a big stick and they just marked out notches on that big stick so that rather than having to take their little inch block and move it along, they could just hold that stick up there and count how many notches it covered the length of the object. That was the first ruler, the beginnings of the first ruler. So all those changes in technology, because of King Edward, I mean, it's kind of an egotistic statement to say, we're going to use my thumb and my foot, but King Edward's declaration actually did open up the door for a lot of advances in measurement. Bigger than a foot, of course, we usually jump up to the yard. We know a yard is 3 feet. A lot of people think of the yard as being the length of your stride. And it is about a yard, but that's not where it comes from. Yard is either from the center of your chest or the tip of your nose to the end of your outstretched arm. It was a tailor's unit. If you ever watch somebody buy fabric from an experienced tailor, they'll grab the fabric, they'll go 1, 2, 3. They're measuring out yards. So, of course, King Edward declared that his outstretched arm was the official yard of the land. And like you said, because once we developed the rulers, there were some intermediate units that weren't necessary anymore. One of them was a cubit. The cubit was from the tip of your fingers to the point of your elbow. Now, people have grown a lot larger in recent years, but back then that was about 16 inches. Now, if you think about it, we're in industry, there's a lot of stuff that's spaced 16 inches apart. Well, that's the construction industry. Traditionally, it's not so much now, but traditionally, Floor joists were 16 inches apart. Wall studs were 16 inches apart. Roof rafters were 16 inches apart. They were spaced 1 cubit. You just stuck your arm in there, put the next one up against, and that's where it went. So every house was a little bit different based on the size of the arm of the carpenter who was building it. It was really inefficient. You weren't going to take your thumbs and count them out, or take a foot was too close together, and they weren't going to take a foot and do like 1.5 feet or something like that. They wanted a unit that they could use, one right away. Well, when they started developing rulers, now they could have markings on that ruler for the spacing. They didn't need the cubit anymore. They just used 16 inches or 1.5 feet or whatever unit worked for them. That ruler allowed them to get rid of the cubit. It was an abandoned unit. There are other units that are bigger than a yard, like a fathom. We're not going to use a fathom in here, but a fathom was 6 feet. It was a sailor's unit. A fathom was the shallowest water that most of your trading vessels could go through without hitting bottom. The way they measured the fathom, literally they'd take one of the tallest sailors on the boat and throw them overboard. If their head stuck up out of the water, it was too shallow to navigate through. I hope they pulled them back in, but who knows? It was different times. One of those units that's not quite as popular that we are going to use is a rod. A rod is 16.5 feet or 16.5 feet or 5.5 or 5.5 yards. A rod was originally a shepherd's tool. They had the staff, which was the hook, kind of like you see with little Bo Peep. It was used to hook the animals around the neck so that they could shave their wool, shear the wool, or attend any medical needs. The rod was a defensive weapon. Literally, it was a big stick. They'd cut down a sapling tree, debranch it, and they'd use that to fight away wild animals. If a wolf or whatever threatened the herd, that rod was their defensive weapon. That's what they used to chase it away. So how did it become a unit of measurement? Well, you're going to have to pretend I can draw here for a minute. Let's say that Dennis and I both have some sheep. Sheep looks an awful lot like a bear, but that's okay. And I send my sheep down in the valley to pasture, and Dennis sends his down there to pasture. Okay, I'm done trying to draw sheep because those are looking like all sorts of different animals but a sheep. But anyway, at the end of the day, I say I have 12 sheep, and Dennis says, well, I have 15 sheep. And we go to get our sheep, and there's only 20 sheep down there. Well, one or both of us were lying. And, of course, that caused some pretty serious conflicts between people. With cattle and horses, they settled that conflict with branding. That burnt mark, that permanent mark in their skin that could be seen very readily to identify who their owner was. Well, with sheep, that didn't work out very well for several reasons. One is their skin was a little more delicate, so it was hard to brand them enough to get it permanent without doing any real damage. Second, wool grows in pretty thick. Cows and horses are short-haired, so that brand stays visible. On a sheep, that wool grows out thick enough that you'd have to pull the wool out to see the brand, making it not real useful. And then the third big reason, which, I don't know, this shouldn't amuse me so much, but it does. Wool is pretty flammable. I'm sorry, I'm just picturing the flaming sheep running across the yard, jumping into the lake. But so that type of identification wasn't practical. Ear tag technology existed, but it wasn't readily available. So what they did was, I would say, okay, I'm going to pasture my sheep over here. Dennis, you're going to pasture yours over there. We're going to keep them separate. This is really the beginnings of dividing up land and land ownership. To make sure that we had the same size, I'd take my rod and I'd put it on the ground. We find some major landmark, like let's say a big rock, that tan blob's a big rock. I'd put my rod on the ground and say that's 1. Well, Dennis would put his rod end to end. There's 2. Then I'd grab mine and flip them over. That's 3. So we'd count out, maybe it's 40 rods by 60 rods or whatever. We both have the same amount of land to use, so we're good to go. To this day, if you look at the official survey of land, the legal description, it is marked out in rods and chains. A chain, again, we won't use a chain in this class either, but a chain is 4 rods. A chain is actually a significant unit of measurement because our acre is based off of a chain. We'll talk about that when we look at units of areas in a few days. Bigger than a rod, there were other units like a furlong. A furlong is about 1/8 of a mile. It's exactly 1/8 of a mile now. Believe it or not, a furlong was the longest distance that the average horse could run at full speed with a rider on it before it had to rest. That's not a very long time, but you think of like the Kentucky Derby and those big horse races. Those are 1.25 miles or 1.5 miles. First of all, those horses are not running full speed throughout all that. The jockey is making sure they reserve some energy. Second, that jockey weighs like 70 pounds, so they're not fully loaded like they would be with a full-size rider on them. And like I said, there's other units in there. We're going to jump up, of course, to the popular one, the mile. The standard land-based mile. There is a nautical mile or a knot that's actually a little bit longer than a mile, but we're not going to talk about that in this class either. The mile, there's a lot of rumors as to where the mile came from. One of them was, the distance that King Edward could see out the window from his throne. The one that I think is the most reliable comes from the Roman military. The Greek-Roman prefix mil is 1,000. If you look at your mill rate on your taxes, if you have a mill rate of 22, that means you pay $22 for every $1,000 of value on your property. Excuse me. So a mile was 1,000 paces of a Roman soldier marching in formation. Now a pace was starting on your left foot, going to your right foot, and then back to your left foot. That makes sense. That'd be about a little over 5 feet, so 5,280 yards for 1,000 of them, or 5,280 feet for 1,000 of those is about right. So a mile was 5,280 feet, or 1,760 yards. These units were never intended to work together. In fact, at the time King Edward made his declaration, my thumb is the inch, my foot is the foot, and all that, there were not 12 of his thumbs in his foot, and there were not 3 of his feet in his yard. A couple hundred years later, those measurements were all adjusted a little bit to make them fit together. Up until that point, if you measured something in feet and I measured something else in inches, there was no way to compare to tell which one was longer or shorter. One of us was going to have to go back and remeasure in the other unit. There was no conversion from one to the other. Each of these units was designed for a specific purpose, for measuring specific things. Nobody had ever thought about changing from one unit to another until, like I said, literally thousands of years later. That's why we have all these really sloppy conversions. And like I said, it was King Edward's declaration that allowed us to eventually adjust those and make them fit together. Now, a side note to that, King Edward was not the only ruler in the world. There were other kingdoms spread around the world, and there were other leaders, rulers, who made the same declaration at around that same time. So from one region to the next, the inch might not be the same length, or the foot might not be the same length, depending on what leader declared their body to be the official measurement of the land in that region. That becomes very important when we look at one of our next steps. But anyway, because of these awkward conversions, it's not so simple to go from one unit to the next. Now, most of us, of course, know that if we have 4 feet, and I'm converting that into inches, Many of you could probably just rattle that off as 48 inches. You know, there's 12 inches in a foot. 4 times 12 is 48. If we didn't know that, the way we would actually go about that conversion is we would make the 4 feet into a fraction. We'd put it over 1. Now, if you recall, when we were actually working with fractions, when I had 3/4, I could multiply by 5 over 5. 3 times 5 would be 15. 4 times 5 would be 20. And it would give me an equivalent fraction. 15/20 is exactly the same value as 3/4. This 5 over 5 is what we call the unity fraction. It equals 1 because the numerator and the denominator have the exact same value. Well, to convert our measurements, we use a version of that unity fraction. We have feet, and we're trying to get rid of feet. So I'm going to put feet on bottom of that fraction. The feet will cross cancel out when we do our multiplication. 1 foot equals 12 inches. So as I said, the feet cross cancel out. 4 times 12 inches is 48 inches. 1 times 1 is 1. So 48 over 1, which is just 48 inches. Now, like I said, that one most of you probably could have done in your head without having to write out a conversion factor. So let's look at one that you don't know so readily, like 99 feet converted into rods. Let's start out with our 99 feet over 1. Once again, we're trying to get rid of feet, so I'm going to put feet on bottom so that they'll cancel out. We're going into rods, so rods go on top. Now, rods is the longer unit, so I put 1 with the rods, and 1 rod is 16.5 feet. So the feet do cancel out. So now we've got 99 times 1 rod, that's 99 rods. 1 times 16.5 is 16.5. And now we have to divide. 99 rods divided by 16.5 is 6 rods. So 99 feet becomes 6 rods. Well, that standard system standard measurement is what we call an evolved system. Now, evolves, the word evolution or evolve to us, to a lot of people makes you think, well, that's fancy or very complex. And it is complex, but it's not well thought out. Evolved really means there was a need and adjustments were made to fit that need. And more needs occurred, adjustments were made. And that's really what the standard system was. Is it met needs and we made adjustments to it as the needs changed. And it was never really planned out. That's why we have those awkward conversions, 3 feet in a yard and 12 inches in a foot and all that. Because of that, in the 1800s, actually the late 1800s, a group of scientists decided they wanted to develop the metric system. The metric system is a planned system. It was planned. By planned, I mean they actually sat down and designed it so that the units would work together. They had literally had thousands of years experience working with the standard system. They knew what worked well and they knew what was clumsy. So they kept the ideas that worked well and they tried to work around or get rid of those ones that were kind of a pain to deal with, like the odd conversions, 16.5 feet in a rod, things like that. They wanted to get rid of them. So because of that, the metric system has kind of taken over in the world. The U.S., for some reason, has not let go of the standard system. But even though it's called the standard system, like we said, it was not standard. A foot was very different in length from one region to the next. In fact, there were parts of the world where a foot was not 12 inches. There's a different number of inches in that foot because of the fact that the different ruler had made that declaration, a different leader made that declaration. The metric system was not only consistent and planned, but it was made to be easy. There was actually a logical step from one unit to the next as to how the sizes were created. Brings us to the question, of course, is will the U.S. switch to the metric system? Who knows? We will switch over eventually. It's going to happen. I'm actually shocked we've resisted it so far. In about 1988, when I was in middle school science class, middle school science teacher was pounding into us. Within 10 years, the U.S. is going to be switched over to the metric system. And they sincerely thought that's what was going to happen. Well, that's been 30 years ago, and we're not switched yet. So it's a lot of resistance happening way slower than we thought. In fact, there are a lot of things that were metric, where we're using metric units that have actually pulled back to standard units. The way the United States has done is they've left it up to each individual government regulatory agency to make the switch. Like right now, you cannot buy a pound of gunpowder or a pound keg of tobacco. You have to buy it as a half a kilogram of gunpowder, or alcohol. You can't buy a quart of alcohol anymore. You have to buy a 0.75 liter. The Department of Alcohol, Tobacco, and Firearms switched over to the metric system, 25 years ago. And the FDA is in the process of making that switch. You notice all your food is labeled grams and milligrams, not drams and ounces. You still have fluid ounces on your soda bottles, but milliliters and liters are right next to it. So that switch is coming. Other things are going to be slower. Most of your international companies, like IBM, made this announcement about 8 years ago, that they were going to do all their manufacturing was going to be done in metric units, whether it was done in the U.S. or in other countries. And their first year, they figured it saved them over $8 million. I don't remember the exact number, but it was 8-point-some million. Because when they made their plans for parts, they didn't have to put both units on it. Didn't have to do unit conversions from one system to another. And because there's round off in those conversions, they had more consistency with their parts. Parts produced in another country fit better with the parts produced in the U.S. because there wasn't that round off in the conversions. So everything was, they were starting to, the whole company thinks in metric rather than designing in standard units and converting it to metric, which avoided a lot of expenses. So I've talked up the metric system as being a planned system that makes more sense. One of the biggest goals of the metric system was not to have all these different units. Every type of measurement has exactly one unit that is used. And for length, that unit is the meter. Now, I'm not in my classroom, so I don't have a meter stick that I can hold up for you anymore. But a meter is about 36.39 yards, or 39 inches. A little bit longer than a yard. A yard is 36. Sorry, let me say that again. The meter is about 39.39 inches, where a yard is 36. So the meter is a little more than 3 inches longer than a yard. When I was young and I first learned the metric system, it always puzzled me why they didn't make the meter equal a yard. Well, they actually did. You remember we said different rulers made that declaration. Well, the metric system was developed in Switzerland. The meter is equivalent to the Swiss yard. So they are the same. You might say, well, that's silly. Why didn't they use the U.S. yard? Remember, this happened in the late 1800s. They created this, 1880s to be exact. In the 1880s, the United States was not a world power. The United States did not really become recognized on the world scene until World War I and into World War II. So the 1920 to 1940 was really when U.S. started being recognized by other countries as being a force in the world. So in the 1880s, nobody really cared about what the U.S. wanted. So they didn't think twice about the U.S. yard. It was the Swiss yard is what they used. So that meter is the main unit of length, abbreviated with just an M. If we had to measure things that were significantly smaller than a meter, they used metric prefixes that were the same for every unit to make it smaller. Like the metric prefix deci is 1/10. So dm is a decimeter, which is a tenth of a meter. Prefix centi is 1/100th. So cm is a centimeter, which is 100th of a meter. We talked about mil, meaning 1,000. Milli means 1,000th. So mm is a millimeter, which is 1,000th of a meter. Now, they didn't go 10,000, 100,000. They skipped over those to get to a millionth. Millionth was micro. Now, the abbreviation for micro, since they already used M for millimeters, is this Greek letter mu. Looks like kind of a funny-looking U or a P with the top left open. So mu M was a micrometer. If any of you have ever had any experience with first responders or anything like that in the medical fields, because the medical field was one of the first industries to have to keyboard all their records into computer records, there is no mu key on the keyboard, so they use MC for micro. So MCM is a micrometer in the medical fields. So just be aware of that if you see it. You can see it abbreviated either way. Then we could go down to a billionth, which I don't know if I have enough room for 9 zeros. We'll try to squeeze them in. That was nano. NM is a nanometer. You don't hear as much about it anymore, but about 10 years ago, you heard a lot about nanotechnology and nanoscience. All that is the science of things that are really, really small. A nanometer is about the size, close to the size of an atom, depending on what type of element you're looking at. So that's all nanoscience was looking at things that are the size of an atom. Going larger than a meter, we had deca. Deca meant 10. Now, we already used dm for decimeter, so for decameter, they used dam. So a decameter was 10 meters. Hecto was 100. So hm was a hectometer, or 100 meters. And kilo is 1,000. So kilometer, km, is 1,000 meters. Then, of course, they skipped 10,000 and 100,000 again and went up to a million. Mega was a million. Notice I spelt that with a capital M because we abbreviate it with a capital M. So capital M, little m is a megameter, which was a million meters. And then, of course, we did have a billion meters, which is a gigameter, and a trillion, which is a tera. For those of you that are into computers, you might recognize the kilobyte, megabyte, gigabyte, terabyte. Same prefix. Those are just metric prefixes. They talk about making things larger like that. Great thing in the metric system is because these prefixes are all set up that as I move from one unit to the next, I'm just multiplying or dividing by 10. Converting in the metric system is all multiplying or dividing by 10. And when we multiply or divide by 10, we just move the decimal point a spot. So if I have 0.32 meters and I want to convert it into millimeters, I just look at my chart here. From meters to millimeters, I'm moving 3 spots to the right. My decimal point just has to move 3 spots to the right. I go 1, 2, and I have to add a 0. That's 320 millimeters. Or I might have 5,100 centimeters, converting into meters. Well, again, from centimeters to meters, that's 2 spots to the left on my chart. So my decimal point, it's not written here, so we assume it's at the end of the number, goes 2 spots to the left. That's 51 meters. Or I might have 29 millimeters, and I want to convert it into centimeters. Well, from millimeters to centimeters is 1 spot to the left on the chart. My decimal goes one spot to the left. That becomes 2.9 centimeters. So for today, time to give you some homework. For today, if you look in Blackboard, there's a packet posted out there. In that packet, it's page 237 of the packet, 1 through 12. That's converting standard measurements. And then page 265 in the packet, 6 through 14 is converting metric measurements. So that's all of our new material for today. So I will give you the rest of the time here, or last 12 or 13 minutes to get started on your homework if you like. I will be on the network here to answer